Welcome back to my YouTube channel. We're still under strength of material N6. We're still under combined bending and direct stress. So we've given this is a clamp. We've given this welding clamp. Says the welding clamp in figure 1 is made from, we have given 25 millimeter thick mild steel where the maximum tensile stress must be limited. We've given the must be limited to that. So here we can see figure 1 now says calculate 3.1 the depth of the clamp if the force is 4 kilonewton is applied. All right, we want the force on the clamp. It's what we want. It says calculated depth. Okay, we have to calculate the depth. All right, so how can you go about calculating the depth? All right, so you can start by saying, let's calculate the bending moment. We know it's force multiplied by what? By eccentric distance. We have given the force that is applied. They said is 40 kilonewton. 4 kilonewton this time 10 to the power of 3. Eccentric is the force where this force will be applied until the center, will be the distance, the 100 until the center of this section. So eccentric will simply equals to what? 100 is the same as 0, 0.1 plus the you have d divided by 2 will be 0, 0.5 d. All right, remember it's where the force is applied until where? To the center of the object where it's bending, because this object, it will bend in this format. That part will bend like this. You have to see that. All right, so because when you apply the force like this thing will bend like this. That part here, this portion will bend in that format. You must see that. So that is what we have now in terms of what? In terms of d. Can call this equation 1. It's our bending moment in terms of d. So let me try and calculate the direct stress. Direct stress, we know it's force divided by area. The force is 4 times 10 to the power of 3. The area, we are focusing on this cross section that we are given there. As you can see, it's a rectangle. So we've given, they said the width there, the thickness there. We've given the thickness, which is 25. Right, that means the thickness P there will be 25 millimeter, and we have depth. So the area will simply equals to 25 is the same as 0, 0.025 multiplied by our depth, which is d. So the area here will be 0, 0.025 times our depth, like that. So this is our direct stress. So let me try and simplify this further. If I simplify this, I can punch this on my calculator. Should obtain, this will be direct stress will be, if I punch that, I will obtain something like 160 times 10 to the power of 3 divided by d. So also here you can simplify further, can distribute there. If you want to distribute, let's say you are distributing there, you'll multiply this by that and also multiply it by that. So if you distribute this multiplied by 0, 0.1 will simply give you 400, and then this you distribute multiply by 0, 0.5d will be plus 2000d. If you want, remember this is simply our equation 1. I'm just simplifying that equation if you want. All right, so even if you don't show equation, as long as you will understand what you're doing. So this force is acting where, as you can see, this direction on the x-axis, this is an x path, is acting like this. So our I, even the bend, this thing will bend on the x-axis. As you can see, this bend is bending on the x-axis. So we'll use the bending. Our moment will be moment of inertia will be taking along the x-axis, whereby we know we're focusing on that cross section will be b, depth cubed divided by 12. So what is our depth? B there, whereby is 12, but now 12 is okay. Is what is thickness is 25, whereby 25 is the same as 0, 0,025. We together multiply by the depth, whereby is d, then will be d cubed divided by 12. So I can try and punch this on my calculator. We can obtain this to be 2,083 times 10 to the power of minus 3 d cubed. This is our ixx. Alright, so you can also now determine the bending stress. We know the bending stress is a bending moment multiplied by y divided by I x-axis. Alright, we know this bending actually is a bending about what? X-axis, bending on the x-axis part anyways, but as you can see, then this our bending is the whole of that. It's what? 400 plus 2000 d, isn't it? Multiply by y. Remember, you've given that rectangle like this. We have 25, you have depth. Y is simply is that part there. So the y, so you divide the depth will divide it by 2. This will be 0, remember it's the same as d. You divide by 2 will be 0, 0,5d. So 0, 0,5d. That is what we obtained there. So far, are we together? Alright, so this is what we have there. Hopefully we are together there. So okay, then this must be divided by ixx, which is 2,0833 times 10 to the power of minus 3 d cubed. So yeah, this is what we have. So we can have our bending stress along x-axis, even if I don't show this, but yeah, we know this is our bending stress. So what can you do here? I can multiply this like that. I can distribute that 400 times 0, 0,5d. You understand? Then distribute here again will be plus 2000d times 0, 0,5d. So all these must be divided by what? Because this thing is dividing the whole of this, so will be this divided by 0, by 2, 0, 0,833 times 10 to the power of minus 3 d cubed. You understand? This part alone will be divided like that. Also, you can divide the second one by 2, 0,0833 times 10 to the power of minus 3 d cubed. So you can simply punch this. You can divide this. You can punch this on the calculator. So, but we know d will cancel with one of the d there. So here we'll have to d squared, because so I'm punching that. on the calculator, should obtain 96001 comma 536 divide. Since this d will cancel with d cubed, here we're left with d squared. Then we have our plus here. Again, we can punch these numbers, as you can see, like that. Then you can multiply these two, will be d squared there. So punching that, we'll obtain 48007 comma 6801 d cubed, isn't it? Divide by d squared divided by d cubed. These two will multiply, but now this and this will cancel, so we're left with what? With d only, since here d, because this is cubed. All right, this is what you have now. You have, this is our bending stress actual. This is simply, this equation represent our bending stress. This will be our bending stress, nothing special there. So we have the bending stress. They said we should calculate T, but we know that the resultant stress is given by the direct stress plus the bending stress. All right, we are given this guy here. This you have calculated. This you have calculated in terms of T. So they said the maximum tensile stress is this. Obvious, those are resulted is 8. We have tensile. Check here, we don't have maximum what you've given. This is a direct, this is a bending, so this will go here. We have 8 times 10 to the power of 6 must be equal, what will be the direct? Here is a direct. We did determine direct is this, the 160 times 10 to the power of 3 d, 160 times 10 power of 3 divided by what? By d. Are we together? Plus now the bending stress. So the bending stress is the whole of this. So be plus 96001 comma 536 divided by d squared plus 48007 comma 6801 divided by d. All right, so this is what we have now. This is what we have. So how can you go about manipulating this? Okay, I will use my math. I will multiply all of these. I will divide by this number here times 10 to the power of 3. It's the same as 1 over 10 raised to the power of 6, everything. So if I multiply this here, this and that will cancel. Then I will multiply here. Here we're left with 80. So here we'll simply have 160. This will be 160 times 10 to the power of 3 divided by 10 raised to the power of 60. If I punch this on my calculator, I will obtain what is this? 0, 208. All right, so I have D here. You see, must also here I do the same thing. I multiply this here. This will be 96001 comma 536 divided by 10 to the power of 6. You have D. I punch this again. I will obtain this to be what? Okay, this will be um but let me just do like this. We have D, I have D here, I also have D. Can simply add these two. If I add those twos, I'm adding the twos there. I will simply add those two. I will get 208 007 comma 68 01 divided by D. Alright, plus 96001 comma 536 divided by D squared. Now, okay, yeah, remember here I still have 80 times 10 to the power of 6. I make this easy, so then I can divide here by 10 raised to the power of 6. You can use any maths that you prefer. You can use any maths here actually. You can divide this by 10 to the power of 6, but all throughout. Divide by 10 to the power of 6 throughout. Divide by 10 to the power of 6. So this and this will cancel. I'm left with 80. You can use any maths. Then I will punch this on my calculator. I will obtain 0,208, right, divided by D, plus, then I punch this, then I will obtain 0,096 divided by D squared. It's any method that you use, then I'll multiply both sides by D squared. Alright, so 80 multiplied by D squared will be D squared. This multiplied by this, what we are going to have there, D will cancel with one of the D's here, so left with 0,208 D. Alright, plus, then I multiply this here, this D and D will cancel, or left with 0,096. So here I have 80D squared. I take this to the other side, would be minus 208D minus 0,096. This must be equal to 0. So this is simply a quadratic. As you can see, you know the quadratic, you want D quadratic, you know, minus B plus or minus the square root of B squared. You simply apply your quadratic, minus 4AC divided by 2A. So B is this. We have negative value, so have negative 0,208. Alright, plus or minus the square root. B is still this, negative 0,208 squared minus 4. A is 80. What about C? C is this, is 0,096. So divide this by 2, then A, it's 80. Alright, punching this on a calculator, we'll have this to be, do not, the one that is negative, just leave the one which is negative, take the positive one, will be 97,1 millimeter when I multiply per 1000. Okay, I have the depth, I just calculated it. All these steps that you're supposed to take, it's your 9 marks. Then we have 3.2 says the minimum resultant stress in the clamp and the nature. All right, the minimum we must have now. Okay, remember the minimum stress, it's a resultant minimum stress is simply equals to direct minus the bending. What about the maximum? The maximum stress, the maximum resultant stress will be direct the maximum resultant stress will be direct plus bending. This is like this. Do not forget, when it's minimum you subtract, when it's maximum you add. So but there they wanted us to determine what the minimum. This is what we'll use. So we have to find, but however now we know the size of what the depth now will be good, because the bending stress and the direct stress we have it. This is the bending stress, all of this formula there, then the direct is this guy. So let's calculate the bending. The direct we've seen it was 160 times 10 to the power of 3 divided by d. But now we have calculated the depth, which is this 79.1 in meters. It's the same as 0.0791. So punch this, I'll obtain this guy to be 2.023 megapascal. So let's find now the bending. It's a long one. The bending, it was before, it was 9609,536. Hmm. 96 536 obvious divided by d squared plus 160 times 10 to the power of 3 divided by d. Here it is. Still remember our direct. Here it is, our bending. Yeah, I think we have it here. So we have our bending stress. Now we know the depth. We'll have 9609,536. This is not 9, is 001. Here 001, 536. All right, the depth is this 0.0791, but we have squared there. We square this plus 160 times 10 to the power of 3 divided by 0.0791. So this guy will be equals to what? The bending stress will be what when I'm punching this. Would have 77,977 megapascal. So we have this. Now we can use this formula here. So we know that the minimum resultant stress is equal to direct stress minus the bending stress. The bending stress is this 2,023 2,023 minus 77,977. Punching this, you'll obtain, they said we should determine even the H, so this will be negative 75,953 megapascal. So since it's negative, that means this is what is compressive, so this would be 75,953 megapascal. This is simply what the compressive stress. So that is it. So thank you for watching, and then do not forget to subscribe to my YouTube channel and click the notification bell so that you'll be notified whenever I post a new video.